Pascal knew that pressure was really important. You've experienced pressure before. If you've ever tried to cut an apple with something fat, like a piece of wood, it doesn't really work. The force that I'm applying is spread over this whole area of the wood, and it just doesn't squish the apple. Like I guess if I really crushed it, I could, but you can use a knife. A knife is a wedge, and it's designed to use Pascal's idea. If you take the force and you apply it over a really skinny area, you can really increase the pressure and cut right through the apple. Pascal realized that this works with all sorts of things. If you take any sort of pressure, like when you're throwing a punch, the force that you have in your muscles is the force that you have to work with. And if you spread that punch over your whole fist, it's not going to be a whole lot of pressure applied. Remember, pressure is equal to force, that's a constant, divided by the area. So if you divide by a big number, like the square area of all your knuckles, it's not going to be a very big result. Whereas if you punch and only hit with 2 knuckles, like they teach you how to do in martial arts, you'll learn that the pressure is much more powerful. The force is the same, the muscles are your muscles, but the area over which you're applying the force is smaller. So force divided by area, if you divide by a smaller number, you get a bigger answer. So we're going to use that property to figure out how we can amplify forces. Syringes are really cool, because if you hook 2 syringes up, and unfortunately at home here I don't have any tubing, but if you put a tube between 2 syringes, when you push in the one syringe, it will push the fluid along the tube and it will push the other syringe out. Now, while that can kind of create just a fun toy to play with when you're sitting with your friends, it actually creates a very powerful mechanical device. You can apply a force over here and have the force transmitted all the way over here. And this is what Pascal was doing when he was inventing the syringe. He wanted to mess around with gases and liquids and see how they behaved under pressure and what he could do with that. Now, he can use that formula, pressure equals the force divided by the area, to create some really cool things. We've gone a long way from where Pascal was. Today we use hydraulics, which is pushing liquids through pressurized systems, to have all kinds of cool machines, like this digger. These are basically just big syringes, and inside the syringe is a liquid called hydraulic fluid, and you can see the hose coming off it up here. That hose is connected inside the digger to a big pressurized pump, and what they're doing is they pressurize the fluid and they force it through this syringe, and the plunger pushes the digger arm out and it scoops up dirt. There's another one over here, and you flip a lever and you throw the hydraulic fluid through this hose here. And you can pull the bucket up or push it down depending on where you force your fluids. You can see more of them over here. Remember how when I first put water into the syringe, we saw that you couldn't compress the water? Well, that's why fluids are so useful when we're building things. If you want no compressibility in your system, you're going to use liquids. And so that's what we call a hydraulic system. Hydraulic systems pressurize liquids, push them with hoses and tubes and syringes, and they can transfer the force that you apply at one part of the machine to another part of the machine. You can also get mechanical advantage with these things. Now, I'm not going to go too far into this, but if you pressurize a system, you pressurize the fluid, you can end up pushing that fluid over a greater area and getting a much larger force. Pascal figured this out. He figured out that because pressure was equal to force times area, he started pressurizing all kinds of things, and he discovered that when you pressurize any sort of fluid, a liquid or a gas, the pressure is the same at all points in the system, and it acts in all directions. So if you pressurize a syringe, for instance, the pressure that I'm creating is equal to the force that I apply to the end of the syringe divided by the area of the plunger, and the pressure is the same everywhere inside the fluid. The same thing in a basketball. If you apply a pressure inside this gas, it'll push out with the same amount of force everywhere inside the basketball. So you don't have like really bouncy parts and less bouncy parts.